In this video, I'll show you how I got monitoring GPIOs working on this Android backup camera app that I created. That turned out to be a bit more involved than the other Android builds like OpenAuto. To do this, you need to cross-compile C code for a Raspberry Pi. Although I've done a fair amount of programming, I've never had to cross-compile before, so it took me quite a bit to figure out the library resources needed for Android on a Raspberry Pi. As a baseline for the C code to watch the GPIOs, I took Lars Kellogg-Stedman's excellent GPIO watch example and modified it for my needs. I have much more details about it, the code changes on my blog if you'd like to check that out. As mentioned though, the cross-compiling is the tricky part here. Note that you need to put in the path for your NDK. I'm highlighting the resources I used here to compile. I spent way too much time trying to figure this out, so I put the details in my blog to hopefully save other people the pain and time. You can check out the code in more detail, but the basics are that the code monitors the GPIOs that you're interested in, and then calls on an associated script for that GPIO. Here I've chosen GPIO 24 to trigger my backup camera app. Like the example code, my setGPIO's program looks for a script called 24, so I had to create one. Here, if the GPIO goes high, I initiate the backup camera app. If it goes low, it reverts to the Android home screen. I'll update this script to call the CarPlay dongle app, as I assume I'll want the infotainment system to go back to CarPlay. The last piece of the puzzle is to have the Raspberry Pi run my GPIO program on boot. This is done using the user init shell script. To make this all happen, you start by actually cross-compiling the C code, and then you need to transfer everything to the Pi. Before you do anything on the Pi though, make sure that you enable developer options. You can check on your Android version, but on mine, I opened the settings, then selected About Tablet, tapped on the build number several times to enable. Then you go back and select System, Advanced, and make sure you have root access for apps in the ADB for debugging. And make sure you turn on the local terminal. Here I just used a USB stick to transfer the files. I created an EV-Manic folder as a temporary repository for the files themselves. From there, after enabling root via the su substitute user command, I copied them to the data local temp folder, as that's the first folder in this Android that I found that allowed me to run programs and scripts. Of course, you just need to make them executable, and then I set GPIO's program to run in the background just to test things out. If this all works as expected, then the setGPIO's program and the 24 script combo will be looking for this backup camera app. So I actually need to install it. I can cover my backup camera app in more detail later, but basically I modified Google's Camera 2 basic example code for my uses. I then compiled it and created an APK to install. This test version of my app is just a version that I still have the menu bar in there, and I have got some toast debug messages to help me debug. I also have some placeholder backup camera guidelines that I'll set to match my Subaru's guideline distances when I actually install this into my project car. Okay, so it seems like the mechanics here seem to work. Now I need to use that user init script to make sure that it all happens automatically on boot up. Like the other files, I transferred into my EV-Manic folder, and then I copied it into the data local folder. Now when the Pi boots, it will run my setGPIO's program in the background. In the future, I can also put other stuff in the user init script. Quick look here, for testing, I added a female header bar for the GPIOs, soldered on GPIO 24 to a momentary button that I push just to test things up. I hope that this video helps other people out, as I hit so many little roadblocks and snags that made the whole process very frustrating. Not many people have done this with kind of a raw Android versus using OpenAuto, so it was kind of a fun path to go down. In the end, you can see that it all came together. I'll put a link below to my blog for all the details of the code, etc. as well. Thanks for watching this video. I hope it was helpful.